All right, we are live.
Okay. So question 3, given the linear regression equation y equals 2 plus 1.5x, what is the y-intercept? That's 2.0.
Yep. Question 4, given the linear equation, the same one, what is the slope? 1.5, right?
Yep.
Question 5, given the linear regression equation y equals -3 plus 0.25x, what is the predicted value of y when x equals 16?
I got 1.
Same.
I'm doing it right now. But I'll probably just trust you guys. It's 1. Yeah, I got 1 as well.
The next 7 questions use the data file. Make sure to use the confidence data for the exponential variable, which is x, and the score data as the response variable, which is y. Make a scatter plot of the map self data of the 3 data shapes introduced in the reading. Which shape best describes these data?
Wait, so okay. Confidence. So are they saying use the confidence rating as y or x? I mean,
x, yeah.
That's dumb. Why wouldn't they just put them in the other order?
that's my big not my biggest problem. Like that's one of my biggest problems with this course is like everything's opposite. Like, I wonder if they're just trying to make sure you pay attention.
Yeah.
But like that was that one we had the other night where it had like 16 different sets of data for like height, weight, this, that, and the other. And you only use 2 of them.
Mm-hmm.
Okay, Bubba, you gotta go play with it.
I got it. Let me know when you guys are. When you got it.
1 sec. I'm getting it all punched in.
Garrett, how old's your son?
He is 17 months.
Okay. Wow. That's a fun time.
Yep. Super active. Loves to play. Hates being just left off to the side. So.
Are you guys teaching him like sign language or anything like that?
We're teaching him Spanish.
I tried doing that with my daughter. It didn't work out very well.
Yeah.
She didn't want to learn it until she heard me talking fluently to someone else. She's like, Daddy, that wasn't English. I'm like, you're right.
Okay, so I got all my values plugged in. Let's see. We're looking at the shape right now. I got a hot.
I got the same hot dog.
Okay.
Yeah, hot dog.
And then for 7, it would be regression is appropriate for this data, correct?
Yeah, A.
And then 8, how many observations? What is it, 139?
Um,
139, yeah. What I got. Or, because it's, yeah, because it's scored the confidence rating. So it's not both columns together, right? It's just how many observations.
Yeah, I think so, because that would, if it was both, I mean, that wouldn't make sense because their 2 are related somehow.
Yeah. Yeah. So I got 139.
Okay.
I got the same.
Y-intercept is 18.69.
Yep. Slope is 12.695.
Yep.
Predicted value of y when x equals 4.
So it would be 12.49 times 4 plus 18.69. I got 69.47.
470, yeah.
Okay. I got 469. So 69.469?
Well, yeah, because it's going to be 4 times 12.695 plus 18.
Yeah. Well, I'm just worried about the 3 decimal places. Are you guys showing?
Oh, yeah. We got 0.469, yeah.
Okay.
So I just rounded up to 0.470.
Just where the next one's 3, I don't know if it would. I don't know.
Actually, no, you're right. It should just be 469.
Yeah. Okay. Number 12. The confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for the values of x? Rounded 3 decimal hint, because there is a positive correlation We can use the largest x value to find the largest predicted value of y. Okay.
I don't understand that question. Confidence indicators.
Well, positive correlation means generally like
No, I
the
understand
level
that.
of x goes up y. So I just imagine it would be 6, right? What is the maximum predicted?
Well, so the maximum predicted value of y for the values of x. So what I did, I don't know if this is right, but I looked for the highest value of x, which is what that hint says, which is 6. And then if you plug 6 into the x to find y hat, you get 94.859.
But is this, where did you get your slope?
So I used the exact same formula that we just used, because it's asking what the highest value of y is. So that y hat, so the y is equal to b0 plus b1 times x. It's saying for the maximum value of x.
Oh, I see what you're saying.
So I looked for the highest value of x out of our data, and we have a 6 in there.
Yeah, there's 2.
Yeah, so I plugged 6 into the same exact equation that we used for number 11, and I got 94.859, which means that the highest y value from our set of data is going to be, for the highest value we can get is going to be,
what,
yeah,
94.860. Is that what you got?
94.8. No, I got 0.859.
Yeah, that's what I got too.
Yeah, I'm just using my phone for the calculation, so it's probably not going to give me 3 decimals here.
Yeah, no, you're good. I just built a formula into Excel. It just makes it easier.
That's what I did.
Yeah, so 94.859. Perfect.
Okay, 13. How many explanatory independent variables are present in simple linear regressions? Just one, right?
Yeah, because
it's just simple. It's
you have one x. Yeah.
And then how many responses dependent variables are present in simple linear regression? Those are the dependent. So it can be 2 or more, though, right? Or is it just 2?
Well,
we've only learned just 2, so I don't know. Sorry. We've only learned up to 1. We haven't done anything.
So wouldn't it just be 1 to 1? Like there's one x, there's one y.
Yeah. Sorry, I was just thinking, oh well, there's one independent, one dependent, so I was thinking 2.
Hey, you're thinking about next week's lesson. That's that's what Matt said about the ANOVA test. He's like, oh yeah, we haven't learned 3 times yet, and then there's the next week.
Hey, what are you doing?
Yeah.
Okay, so we going with 1 then for 14?
Yeah.
Yeah, I would say 1, just because we learned 1x, 1y.
Yeah.
And it's simple. It doesn't sound simple when you're doing 1 to 2 or 1 to 3.
Yeah, right. Plus the Excel sheet doesn't give us more than one dependent variable. So
the only thing I think of is if it's saying like how many y-intercepts there are, and that would be dependent on what we multiply it by x. But that seems way too complex of a question for all the others here.
Yeah, that is way too. We haven't quite made it to that level. Although in the lesson it says that if we wanted to do anything to advanced statistics, that we can talk to our professors and see, learn about that stuff.
Yeah, I'm okay.
All right, question 15. A company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include hat size, circumference of the hat, and lengths of the major and minor axes. Meaning the company wants to predict size of hat given the circumference. What is the response variable? So
wouldn't it be the size of the hat because it's a variable being predicted?
Well, the response variable is what's
dependent.
It's dependent. It's this is because of that.
Right. So
because they're measuring the hat size, circumference, and the lengths, they can then determine what?
I would say it's A. So I would say the explanatory variable X would be the circumference, and therefore if the circumference is X, then the hat size is
right.
whatever.
Yeah, I'm with you on that. Well,
So
A, because it is being used to predict the circumference. Yeah, I would say A.
Oh, yeah. Yeah, I would say A as well. Sorry, I'm reading through them. Okay.
All right, let's see how this turned out. Mine always takes so long to submit. It scares me.
We got 100%.
Nice.
You
missed one, Ryan?
No. My quiz apparently didn't save and it exited it out, so I need to go back and get a couple more. So 8, we put observations was 139, right?
139 for 8. Yep.
Y-intercept was 18.690, and then the slope was 12.695.
Yes.
I was wondering why I wouldn't save them, and that would be why. There's no answer there. All right. Now I'll submit it. Oh, got them all.
Nice.
Cool.
Awesome.
Now if I can just do that in the homework quiz.
Yeah, right? All right.
We should be allowed to do the homework quizzes together too, but
I know, it'd be so much easier.